The effective airspeed and slipstream. Aim. To observe the effect of an increased speed of airflow over the control surfaces. Considerations. Control effectiveness. The effectiveness of the three main flight controls and the rate at which the aeroplane moves in all three planes, pitch, roll and yaw, depends on the amount of control deflection, the airflow over the control surface, which can be increased by a higher airspeed, and/or slipstream from the propeller. Airspeed. The elevator, ailerons and rudder will all experience an increase at airflow when the aeroplane is flying at a higher airspeed. Each control will feel firmer and only small movement will be required to produce an effective response. All of the flight controls are more effective at high airspeeds. Conversely, at low airspeeds the airflow over each of the flight controls is less and their effectiveness is reduced. The elevator, ailerons and rudder will all feel sloppy and large movements may be required to produce the desired effect. The propeller slipstream. The slipstream from the propeller flows rearwards around the aeroplane in a corkscrew fashion, which increases the airflow over the tail section, making the rudder and elevator more effective. Further, the slipstream increases elevator and rudder effectiveness. The ailerons, being outside the slipstream airflow, are not affected by it and will remain sloppy at low airspeeds irrespective of the power set. The elevator on T-tail aircraft may also be somewhat out of the slipstream and therefore not affected by it to the same extent as the rudder. The slipstream causes a yaw tendency. The slipstream from the propeller flows back in a corkscrew fashion over the tailplane, meeting the fin at an angle of attack. This generates a sideways aerodynamic force, which tends to yaw the nose of the aeroplane. The pilot can balance this yawing effect with rudder pressure. Slipstream effect is most pronounced under conditions of high power and low airspeed, e.g., during a climb, when the corkscrew is tighter and its angle of attack at the fin is greater. Slipstream tends to yaw the aeroplane. The direction of the yaw resulting from the slipstream effect depends on the direction of propeller rotation. If the propeller rotates clockwise when viewed from the cockpit, as is the case for many modern training aircraft, the slipstream passes under the fuselage and strikes the fin on its left-hand side. This causes a tendency for the nose to yaw left, which can be balanced with right rudder. If the propeller rotates anti-clockwise as seen from the cockpit, e.g. the Tiger Moth, Chipmunk, and ARI Super 2, the slipstream passes under the fuselage and strikes the fin on the right-hand side. The nose will tend to yaw right and will require left rudder to balance. Flying the maneuver. To observe the effect of airspeed on the flight controls. First, establish a glide to eliminate the effect of slipstream at a high airspeed and operate each of the three main flight controls. Each one will feel firm and be effective. Then raise the nose to glide at a lower airspeed and operate each of the three main flight controls. Each will feel sloppy and less effective than before. Next, apply climb power, maintaining the same low airspeed by raising the nose. This will introduce a strong slipstream effect, but keep the airspeed effect constant. The elevator and the rudder. Being in the slipstream, will feel firm and effective. The ailerons, which are outside the slipstream, will still feel sloppy and less effective. Airmanship. Maintain a high visual awareness. Keep an eye out for other traffic and remain aware of the position of the aeroplane and the direction to be flown back to the aerodrome. Exert firm, positive, but smooth control over the aeroplane.